Hi, this is Tom, and this is lesson 22, the z-score, part 2, and this is the second video in this series. And let's return to our problem. And the problem was originally that the average American male is 70 inches tall with a standard deviation of 4 inches and is considered to be normally distributed. So we have a mean of 70, a standard deviation of 4, and I've drawn our standard normal curve below. Now, in this part, what we're going to do is we're going to ask the question that, well, what if you know the percentile of interest and want to find out what the corresponding data value is? That's what we're going to do. So I have this example for us on the side. So let's take a look. So here's our example. It says, suppose a basketball coach is recruiting and knows that height is the best chance for success in the sport. The coach tries to only recruit players in the top 10% of height. What is the minimum height to be considered as a recruit for this coach? Well, that's what we're going to find out. So we're going to start by this. If we're in the top, this is the key to this problem is right here. The top 10%, well, the top 10%, those are the tallest people. We want the tallest people to be recruited for our basketball team. Now, I'm going to estimate, and I'm going to estimate that about our top 10% of tallest people are out here in this upper tail. So this is our top 10% of American males by height. And this little bar right here, this is just an estimate. We don't know exactly, but it helps to represent what it is that we're after. That's an estimate. Now, let's recall this. We had that our z-scores is found by some z of x is equal to x minus the mean divided by our standard deviation. Now, in this problem, what we don't know is this. We don't know x. But that's our goal because that'll tell us the minimum height. Now, let's look at our picture. We want players in that pink area. So what we need to do is we need to first find a z-score that would get us to right there. That's the z-score that we need to find. Now, we're going to go back up and take a look at our tables here, and we're going to see how we can do that. So come with me. I'm going to do a little erasing here. And let's see what we can do. All right, now, notice that here's my picture, and I've already shaded it, but let's just clear it off for a second. Notice that this is approximately what we have shaded in our picture down below. This is our top 10%. But the problem is the table doesn't give us the top 10, it just gives us the lower portion. Well, the lower portion we find by taking 1 and subtracting our 10%. And what we find then is the gray region here. The gray region is 90% of our picture. 90%. In other words, what I need to do is we need to find the z-score for 90%. And remember that 90% as a decimal is 0.9000. All right, here we go. So let's look up above in our table. Here's our table up above. And here's the interesting part. Now, somewhere in here, out in the middle of our table, is the answer. And now we're going to read our table in reverse. So let's take a look. Well, if I look right here, that's 89.8. That's getting close to 90%. And if I move over one more, I'm at 8997. That's really close. But look at this. I can even get one step closer. I can get one step closer if I go right here to 0.9015. And notice that then if I come back to the left, that corresponds with 1.29. And then if I go above that, I'm sorry, it corresponds with 1.2, and if I go above that, we get the 0.09. So this says that the 90% is the z-score of 1.29. And that's the number we need to use below. So let's go down below. Oops. And here we go. So now we know that the z-score is 1.29. And now we can figure out the rest of our problem. So that's what we're going to do now. Okay, so let's do this. Now, this time, this is our z-score. This is what we know right here. So let's put that in there. We know that z is going to be 1.29. X, we don't know, so we're going to have to find it. But we know that the mean is 70, and we're going to divide all that by a standard deviation of 4. Now, what we need to do is we need to solve for x, which in other words means we want x all by itself. Here's how we do this. In algebra, there's really only one rule of concern, and that is that whatever you do to one side, you have to do the exact same thing to the other side. So let's make some room here. 1.29, I'm just rewriting, equals x minus 70 over 4. Now, I would recommend that the first thing to do is try to get rid of fractions. So what I'm going to do is multiply both sides of the equation by 4, because that's what you can do in algebra. So my motivation, though, is this. My motivation is if I multiply the right-hand side, then the 4's will cancel. And then all I have to do is I just multiply the result on the left. So 4.129 becomes 5.16. And then on the right, I'm left with an x minus 70. Now, remember, we want x by itself. So on the right-hand side, I have negative 70. Well, I want to cancel that. So I could cancel a negative 70 with a positive 70. So what we're going to do is we are going to add 70 to the right-hand side. So plus 70. And remember, the rule is then you need to do that on the other side as well. So we've done that. And now we have, oops, I should be consistent in my coloring. I have that 75.16 equals x. And that's the answer. So, in other words, a recruit must be 75.16 inches or taller, to be considered by this coach. And most of us don't really think our height in just inches. We often think in feet and inches. So what we can do is we take the 75.16 and we divide it by 12, and we'll get a remainder. So 12 goes into 75. I think it's 6. So 6 times 12, that's 72. We subtract, we get 3.16. And so that's our remainder. And so what we can say is 75.16 inches, or 6 feet 3.16 inches or taller. And that is how we go from having a desired percentage to finding the appropriate data value. Hope that helps, and thanks for watching.